Now in gravitation, we know in Newton's law of gravitation, you have two masses, m1, m2. The distance between them is r. There is a force of attraction between them, and this force of attraction is directly proportional to the product of the masses. It is inversely proportional to distance squared. If both of these expressions are combined, F proportional to m1 m2 by r squared. If you put an equal to sign, here comes the universal gravitational constant. The value of this g is very, very small. It is 6.67 10 to the power minus 11 Newton meter square per kg square. As this g is very, very small, children, this force is a very, very weak force. Now, first we are going to study how acceleration due to gravity changes with altitude. Now, this is my Earth. Earth has mass m. My radius is r. If a mass m is over here, then the force of attraction of the Earth, F, is equal to g, mass of the Earth, into mass of the body divided by distance square, and this is equal to mg. What is g? G is the gravity at this point. Here the value of acceleration due to gravity is g. Now m cancels from both the sides. So gravity on the Earth's surface is gm by r square. Now if the mass is taken at a height h from the Earth's surface, I keep the mass over here, altitude h. Let the gravity at this point be g dash. Now at this point, if I apply the Newton's law of gravitation, F dash is G M M divided by, now the distance is R plus H whole square, and this becomes M G dash. Now M cancels from both the sides. So the gravity at an altitude h, G dash, becomes Gm divided by R plus H whole square. This is the gravity at an altitude h, and this is the gravity on the Earth's surface. Now we have to study how G changes with height h. My altitude here is h. So if I divide the two expressions, G dash by G dash put over here, it is Gm by R plus H whole square. This is Gm by R square. It is Gm by R plus H whole square divided by Gm by R plus H whole square divided by Gm by R square. Now, this Gm cancels from this, becomes R square will go on top divided by R plus H whole square. Now this is R square. From here, if I take R square common, this becomes 1 plus H by R whole square. Now this R square cancels from both the sides. So now what can we write? Now we can write G dash by G is 1 plus H by R whole to the power minus 2. Therefore, G dash is G into 1 plus H by R to the power minus 2. Now this is how G changes with altitude. Now in competitive exams, you won't be able to use calculators. So what happens? This G into 1 plus H by R whole to the power minus 2, you won't be able to do the sums. So in competitive exams, children, they provide such values of H where H is very, very less compared to R. What was H? This was my Earth. H was the height where I was finding the gravity from the Earth's surface. And radius is the radius of the Earth. Now, this height for competitive exams usually they give it very, very small. In that case, h by r term is very small. Now, if this term is very, very small, then for competitive exams, you can expand this binomially. Expanding binomially. And neglecting higher order terms. Now, what is this binomial theorem? For physics children, mostly we need the first term and the second term for a binomial expression, and this can only be applied when h by r is very, very small, when they give the height very small. In that case, this expression g dash can be written as g 1 plus multiply this power to the second term. It is minus 2h by r. There are other terms where you will have h square by r square and other. But when h by r is small, then h square by r square will be smaller. H cube by r cube will be smaller. So those terms are neglected. So we are neglecting the higher order terms. See, you have a very small term, 0.001. Now if you square the term, it becomes smaller. So squaring and cubing a smaller term, it becomes smaller. So we can neglect it. So provided h is very small in the sum, use this formula. Otherwise, use this formula. In ISC, in the school exams, you can use calculator. So this formula is fine. But in competitive exams, you have to, in 99.9% numericals, they give the height very small. So g dash becomes g 1 minus 2h by r. So the calculation becomes easier. This is an assumption, children. This comes from an assumption that h is very, very small. But the actual expression is this one. Actual expression is this one. So, if we study the graph of altitude versus depth, if we study the graph of altitude versus depth, say on the y-axis I plot my g. This is altitude. This side is altitude. And this side is depth. This is on the Earth's surface. For altitude, my real expression is, children, For altitude, my real expression was this one. G dash is G 1 plus h by r to the power minus 2. So for altitude, my expression is G dash is G 1 plus h by r whole to the power minus 2. So the graph will be like this. So the graph will be like this. Say, on the Earth's surface, my acceleration due to gravity is g. As we go up, g decreases, but non-linearly. As we go up, g decreases, but non-linearly. G will decrease, but non-linearly, because this expression is not linear. This expression is not linear. So G decreases with altitude. Non-linearly. It's not a linear graph. If it would have been linear, then the expression would have been y equal to mx plus c. Now, if we go down into a deep mine, how will g change? If we go down into a deep mine, variation of g acceleration due to gravity due to depth. Now this is my Earth. Mass m, radius r. So mass can be written as volume into density of the Earth is uniform. I am considering volume is 4 by 3 pi r cube. It's a sphere. I have a mass over here m. The Earth is attracting it. So the force on this mass is gm m by r square. This gives the body its weight mg. M cancels from both the sides. So gravity on the Earth's surface is gm by r square. M is the mass of the Earth, 4/3 pi r cube into rho. So this is written as 4 by 3 pi r cube into rho. This r square and 1 r cancels. You have here 4 by 3 pi g r rho. 4 by 3 pi g r rho. This is the gravity on the Earth's surface. This is on the Earth's surface. This g is on the Earth's surface. Now I go to a depth h. I go to a depth h. Come down to a depth h. Let me zoom this a little bit. I go down to a depth h. When I come down to a depth h, this is my earth. Now this part of the earth will attract this mass. When I go down a depth h, it is the blue shaded part which will attract the earth. Now the full mass will not attract. So what is this mass which will attract m dash? It is 4 by 3 pi r minus h whole cube. Now the radius is r minus h whole cube into rho. I go down a depth h. So this is my center. This full radius is r. So the radius of the earth which is attracting is r minus h. Only the shaded part will attract. Only this mass will attract. So now if I find out the acceleration due to gravity at a depth h, I want to find out the acceleration due to gravity over here. So let me rub this part. Acceleration due to gravity at a depth h is g dash. So if I write the expression at a depth h, my expression now becomes force F dash is g. Now the full mass will not attract. Only the shaded part will attract the mass m. G m dash m by r minus h whole square. That is equal to m into g dash. M will cancel from both the sides. So g dash now becomes gm by r minus h whole square. This is m dash, children. Only the shaded part of the mass, put it over here. G r minus h whole square. I am substituting the mass m. 4 by 3 pi r minus h whole cube into rho. R minus h whole square cancels, this is 1. So g dash now becomes 4 by 3 pi g r minus h rho. Now I want to compare the gravity. I want to compare the gravity on and at a depth h. So what I do, I just divide. G dash by g. G dash is at a depth h. 4 by 3 pi g r minus h rho divided by 4 by 3 pi g r minus, it is R rho. It is 4 by 3 pi g r rho. Now 4 by 3 pi g cancels, rho cancels. So from here you have g dash by g is r minus h by r. So this becomes 1 minus h by r. Therefore, g dash is g into 1 minus h by r. So the expression tells us that as you go down, g will decrease. As you go down, the g will decrease. So from this expression, as h increases, h means depth, as depth increases, g decreases. So if this is my earth, as you go down the earth, g decreases. And when you come to the center of the earth, from the surface, this is the surface of the earth, go down, go down, go down. At the center, this is the center of the earth. At the center of the earth, at this point, my h is equal to r. And when h is equal to r, when h is equal to r, g dash becomes g 1 minus r by r. So g dash becomes g 1 minus 1, which is 0. So at the center of the earth, my gravity becomes 0. So if I draw the graph which we were drawing, this was the graph which we were drawing. So the graph will be like this. This g will decrease. So the graph will be like this, children. As you go down, the g will decrease, 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 and G is maximum, children, on the Earth's surface. G is maximum on the Earth's surface. G is maximum on the Earth's surface. G decreases with depth linearly. It's a straight line. And G is 0 at the center, means when the depth becomes equal to radius, at this point G becomes 0. So as you go up the Earth's surface, G decreases. As you go down, G decreases, and G becomes 0 at the center of the Earth.